Hey folks, welcome to my channel Number Pen. So there we have the problem on the screen. Integrate the following with respect to x. We have 9x e to the power 3x, right? So what we've been given is dy by dx and we've been asked to find y. My y is nothing but integral of the given expression. So let's write down what's our y. And when I notice my y, I have a 9, I have an x, I have a e to the power 3x, and then I have a dx, right? So I can pull out my 9 because 9 is a constant. Y equals 9 times integral of x into e to the power 3x dx, right? Now, can I solve this by the method of substitution? Right? We've seen a lot of videos in the past where we solved problems in integral calculus using substitution. In this particular problem, I don't think substitution is going to help us out, right? Why is that? I've got an expression e to the power 3x and I've got another x dx, right? That's one way of looking at it. Now, the other way of looking at it is I've got x and I've got e to the power 3x dx. So, either way, am I in a position to connect expression 1 with expression 2, right? So, looks like the answer is no, right? Because whenever we solve problems by method of substitution, always one expression used to be a derivative of the other expression, or we used to reduce it to that level post some form of simplification, right? Now, in this particular problem, we've got two basic functions, x dx and e to the power 3x, or you can look at it as, e to the power 3x dx and x, right? Either way, you cannot solve it by substitution. So this is where integration by parts comes to your rescue, right? So let's write down what is that identity. And if you've not taken a look at my previous video where I discuss integration by parts and the derivation around it, please take a look at it. So this is what integration by parts tells me, right? If u and v are two differentiable functions, then I have integral of u dv equals uv minus integral of v du, right? So as far as integration by parts is concerned, the challenge here is identifying our u and v, right? So in this particular case, let's assume that dv is equal to e to the power 3x dx and my u equals x, right? Now, there is also another possibility where I assume that my dv equals x dx and my u equals e to the power 3x, right? Key to solving all these problems quickly is identifying the right u and v combinations here, right? Now, why did I choose dv equals e to the power 3x dx, right? Because if I choose this dv, it is easier for me to arrive at my v, point number one. And when I do integral of v du, I notice that that also becomes a lot simpler for me, right? Why? We will see that in the subsequent step. Now, if my dv equals e to the power 3x dx, then what is my v? Right now, this is something which is quite simple. We have solved multiple problems of this type. Okay, so I'm not going to go discussing about how we solve this. This is e to the power 3x by 3, right? So I know my v, I know my u, which is x, right? I put it back in the integration by parts identity. So I have integral of x into e to the power 3x dx equals uv. I know my u, I know my v. My u is nothing but x, and my v is nothing but e to the power 3x by 3. Okay, so we write down what is our uv, and then I come to my second part, which is integral of v du. Now that I know my v, I'll have to figure out what is my du, right? Now my u is x, therefore my du equals dx, right? Therefore, my integral of v du becomes 1 by 3 times, I pull out the 1 by 3, e to the power 3x, which is my v part, and my du is nothing but dx, right? I cannot arrive at my integral of x times e to the power 3x dx directly, but using integration by parts, I'm able to do it because I know the answer for integral of v du as well. Why is that? By choosing the right u and v, my integral of v du also is reduced to a simple expression whose antiderivative I know from first principles or some of the identities that you have learned in the recent past, right? So, what is my answer for this? My RHS is what I am writing down now. I have x times e to the power 3x by 3 minus of 1 by 3 times. Again, I have an integral of e to the power 3x dx, which is nothing but e to the power 3x by 3, right? Now, I have a 3 into 3 in the denominator of the second expression. So I'm going to write this as an e to the power 3x by 9. I'm going to eliminate this, right? So this is what I have as integral of x times e to the power 3x dx using integration by parts, right? Now I go back to my y. I rewrite my y as follows. My y equals 9 times. This is what I worked out, integral of x e to the power 3x dx. Now I know that I can do a little bit of simplification. First part of the expression becomes 3 times x into e to the power 3x. Minus, I can cancel out the 9, so I'm left with e to the power 3x. I think I can do one more level of simplification. I can pull out the e to the power 3x out there, and I can take this as e to the power 3x times 3x minus 1 plus a constant c, right? So there we are. I hope you found my content useful. Please do subscribe to my channel and support. Thank you.